Hi everyone, welcome to our video on indefinite integrals involving e to the kx, or really also a to the kx. Now, it's just like, again, derivatives, where I would think the antiderivative of e to something is itself, so it is copied and pasted. So I'm looking kind of like at this one right here, where e to the kx we see is instantly involved. But if there's just a constant multiplier in front of that x, so k we're saying is some constant, all we have to do is divide by that k, and then at the end of it all, add the c to it. And then when it's a different base, it's also very similar. A to the kx just gets divided by k afterwards, but we just also have to remind ourselves, hey, put that natural log of a down below also. Okay, so let's do this. So find the following. So doing these indefinite integrals. So the first one is just the original e to the x rule. I mean, it still follows what's happening here because the value in front would be 1. So let's do it in blue to show I'm doing the antiderivative. So I'm copying that e function. The coefficient in front of the x would be 1. So just to really copy this rule, that's what it would look like. And then we have plus e to the negative x gets copied. And then the coefficient in front is -1. So we divide by -1. And then at the end of it all, add c. And so then, let's go ahead. I'm just going to put it right here for our final answer. E to the x over 1, we could just write as e to the x. The second term we could write as minus e to the negative x. And then plus our constant. There we go. And just like with any antiderivative, you can check by doing the derivative. The derivative of e to the x is e to the x. The derivative of this, the -1, would multiply the -1 to give us positive e to the negative x. And then derivative of a constant is 0. So we see that it matches our original. Check. All right, so let's try another one. So with this, we have 8 would just be hanging out. 8's just hanging out in the front. And then using the rule for the e to the 4t, well, again, I'm just going to copy the e to the 4t. And then I just want to make sure I divide by that constant that I see attached with the variable. So I just need to divide by 4. And then parentheses, and then we'll add our constant at the end. And then, well, like most of these, we'd want to simplify. 8 divided by 4 would become a 2. And then we have e to the 4t still, plus our constant. There's that. And again, very quick check. The derivative rule for e would be to take the 2 and multiply the 4. We would get 8, and then copy and paste the e to the 4t. And then the derivative of c is 0, so yes, it matches. Check. Okay, let's do another one here where the base is not e, it's some other base, but that's okay. It is very similar. Okay, so we have this setup here. Okay, so I'm still just thinking the antiderivative of an exponential function is itself 3 to the t here, and then divide by the coefficient that's with the variable. So it would be 1 just to show it. And then also, because it's not base e, we'd want to make sure to do the natural log of whatever the base is underneath with it. So 1 natural log of 3 all below. And then in our next one, now notice 5 times 10 to the 0.4t. These do not combine. Remember, the order of operations would want to do the power first. So don't fall for the trap and say that this is 50. Just keep that 5 by itself. So it is -5. And then now let's deal with this portion here. So the antiderivative, again, I'm just thinking just copy and paste 10 to the 0.4t. And then I know, hey, it's exponential function, so let's divide by that constant that's attached to the t. So we'll divide by 0.4. And then we have a base that's not e, so we'd want to make sure we do the natural log of that base there, like that, natural log of 10. And then we'll have plus c at the end. Okay, so that's all. It's pretty procedural there. And then we'll clean up what we have. So for the first term, we do have 3 to the t over the natural log of 3, because 1 times natural log of 3 is that. Now, in the second term, we would do the 5 divided by the 0.4. So let's use our calculator real quick here. If you know it right away, that's good too. But 5 divided by 0.4 gives us 12.5. So I'm gonna use the decimal since they use the decimal. So 12.5. So we'll have minus. Oops, I still have the highlighter. Okay, so the highlighted became minus 12.5. And then we'll do times. We'll do the dot symbol like how they did it. Times the 10 to the 0.4t over the natural log of 10. And then plus our constant. And there it is. And again, we could check. Okay, so quick check. The derivative of an exponential function is itself. And then I know that with a base that's not e, it would multiply with the natural log of 3. So we would have natural log of 3 in front, also getting divided by the natural log of 3. So those would just cancel. And then the minus 12.5 would just be hanging out for now. And then doing this derivative, this would require the chain rule, but it is the exponential function, again, already attached, times the natural log of 10, which would divide with that other natural log of 10. So those would just cancel. And then times the derivative of the power, so times 0.4. And 0.4 times 12.5 will be 5. So it will all work out. And it is the same as what we started with. Okay, so that means we did it correctly. Okay, so that's that. So that's when, so e to some constant multiplier, or a, so e is the main one. That's the one that you'll see the most of. Here's a little bit more of a rare case, but it follows something similar. I just try to remember if it's anything with a base other than e, we'll have natural log of that base somewhere involved. Okay, and on antiderivatives, it goes down below. Okay, so that's that. So that's most of our rules, really. So we had our power rule getting involved a lot in the previous video, and then we have these E rules here. So we see a bunch of those all the time. So, and they might combine them, but other than that, that's it. Okay, so that's it for this video. Thanks for watching, and I'll see you again next time.